Bismillahirrahmanirrahim. Assalamu alaikum students. Today our topic is topology of complex numbers. So the topology over here is used in non-technical terms. So we will take its general meaning. So topology of complex numbers or topology of anything is the arrangement of the constituent parts. So over here we will be dealing with the open sets and closed sets. We will see the definitions of the open set, closed sets, and bounded set, annulus, interior points, exterior points, and the boundary of the complex numbers that are related to the complex numbers. So this topic covers the 13.3 sections of your textbook Advanced Engineering Mathematics by Erwin Krasik and 1.5 section of a first course in complex analysis with applications by Dennis Giesel and Shanahan. So the first comes the definition of circle. The set of points Z that satisfy this equation represents a circle of radius rho with center at Z0. So whenever you have this equation tells you that the distance of the points, you are taking all those points whose distance from Z0 is equal to rho. So it must include this circle. This circle contains with center at Z0 and all these points Z and their distance from Z0 is equal to rho. So it is a circle. Another approach to visualize this Z minus Z0 is equal to rho is if you take Z is equal to X plus iota Y and Z0 is equal to X0 plus iota Y0. So this equation becomes X plus iota Y minus X plus X0 plus iota Y0 mod is equal to rho. So it becomes X minus, I'm adding the real part of both the numbers and imaginary part of both the numbers is equal to rho. So if I'm taking the mod, it is equal to X minus X0 square, real part square, and the imaginary part square is equal to square root of this is equal to rho. Taking square on both sides, it becomes rho square. So this where X and Y both are real number, X0, Y0 both are real numbers. So this is equation of a circle with center at X0, Y0, center at X0, Y0, and radius equal to rho. So there's another approach to visualize this thing. Now comes a disk. The set of points Z that satisfy this equation, Z minus Z0 mod is less than equal to rho, represents a disk of radius rho centered at Z0. So the points lie either on the circle, this, or within the circle. So this basically represents a closed disk. That is, closed disk mean we are taking all those points whose distance from the Z0 is less than equal to rho. So over here, the boundary, that is the circle, is also included in this disk, in this closed disk, and the interior of the circle as well is included in this set. So such type of disk is called a closed disk. Closed disk because over here you have the equality sign as well. And if you are just considering the less than sign, then that disk is called an open disk. That is all those points whose distance from Z0 is less than rho. All the points whose distance from the point center Z0 is less than rho, not equal to rho. We are not taking the equality sign over here, so not It is less than rho. So that is called the open disk. So this is my open disk, and the points lie within and not on a circle of radius rho centered at the point Z0. So this set, basically this set is also called a neighborhood of Z0. This is called the neighborhood of Z0. This is. So whenever I'm using the word neighborhood of Z0, it means an open disk with center at Z0 and radius any positive number. So neighborhood of Z0 means an open disk with center at Z0. So if I delete the point Z0, if I exclude the point Z0, that is the point circle, then I have to put this condition on this equation, and the set of points that satisfy this equation is called a deleted neighborhood of Z0 or a punctured open disk, right? So this is a punctured open disk. If I'm taking this condition, 0 is greater than, that is, I am not taking the points Z is equal to Z0. So over here, if we are dealing with the real number system or one-dimensional system, then we have only one dimension, that is a line. And if I'm taking the neighborhood of the point x0, any neighborhood, so I have to take this point and this point. So delta distance. So in R, the neighborhood is x0 minus delta, x0 plus delta. This is an open interval. Open interval about x0 is the neighborhood of x0. And if I am dealing with R square, then the neighborhood of the point Z0 is this open disk with center at Z0 and radius rho, that is this one. You know the difference between the complex numbers and the real numbers? We can draw the real numbers in one dimension, but for complex numbers, we need two dimension. That is, we can draw complex numbers on complex plane. It is because any complex number x0 or xy is equivalent to an ordered pair where both x and y are real numbers, and we can draw these ordered pairs in a plane. So complex numbers can only be plotted on complex plane as well. Okay, this is the concept about neighborhood, and then comes the open set. But before open set, we have to see what is the interior point of a set. So a point Z0 is said to be an interior point of a set S of the complex plane if there exists some neighborhood of Z0 that lies entirely within S. So over here, the word exists some neighborhood of Z0 is important. There must exist some neighborhood of Z0. That is, if I'm considering this set, this blue shaded colored region is a set S. If I'm taking any point Z0, and if its neighborhood, that is this open disk about this point Z0, lies within this set, then I'm saying that Z0 is an interior point of this set S. So I can take this point, I can take this point, any point, and I draw a neighborhood on an open disk with center at Z0 and radius rho, whatever small the rho is, the disk, open disk, or the neighborhood of Z0 is contained in the set S, then that point is called the interior point. So if you are taking this set S and its boundary is this board line, this with this black color, if I'm taking this point, and if I draw an open disk, then some of the points of open disk will contain the interior, will contain the set S, and some of the points will not contain the points of S. That is this one. Whichever neighborhood you take, if you take the radius smaller and smaller, it will, some of the neighborhood of S contains this set S and some outside the set S. So such points are called the boundary points of point S. That is this boundary of S. That is, if every neighborhood of a point Z0 of a set S contains at least one point of S and at least one point not in S, then Z0 is said to be boundary point of S. The collection of boundary points of a set S is called the boundary of S. So over here you can see this is the interior of S, this is the boundary, and this is the exterior. Exterior point is defined as a point that is neither an interior point nor a boundary point of a set S is said to be an exterior point of S, right? So we have defined the interior point and the set S whose every point is an interior point is called an open set. So an open set is a set whose every point is an interior point. Right? So let's see some examples. Over here you can see this example. A, imaginary part of Z is less than 0, which is a lower half plane. Imaginary part of Z means Z is equal to X plus iota Y. So imaginary part of Z is equal to Y. So you have this equation, Y is less than 0. There is no restriction on X because you cannot see any equation or inequality with X. So only the variable which is restricted is Y, and Y is less than 0. So this is my equation, Y equal to 0. So whenever you have to draw the region corresponding to some inequality, first you have to draw the equality. Remember this point. That is, first you will draw the equality, corresponding equality relating to this is Y is equal to 0. And since this is Y less than 0, so I have to include all the region that lies below Y equal to, below the line Y is equal to 0 or below the line, below the x-axis. So over here, Y is equal to 0 is not included. You cannot see any equality sign over here. So this is my region, this shaded region, this blue region is my set, my region that correspond to this inequality. So is it an open set? Yes, it is an open set. I can take any point, all of its points are interior points, and interior points are those points. If I take any point, its neighborhood lies within this set. So imaginary part of Z is less than equal to 0 represents a lower half plane. Lower half plane, you can determine its upper boundary